everyone, this is me Kalam Hussain here, and I am going to present my 13th practicum of computer organization and architecture. So let us dive into the procedure. The first step of the so basically, sorry, let us basically explain the step of the practicum 13. And then the practicum 13 is basically about GPU execution on NVIDIA Jetson Nano, and basically it explains about how Jetson Nano works, and this is the flow chart. The first start program, the first is to switch on just a Jetson Nano and launch Python environment, and after that installing required libraries, and after that we are inputting data, creating vectors A and B, and after that we are performing vector addition using CPU, and after that we are transferring data to CPU to GPU, and after that we are performing vector addition using the GPU, and to the sound step is synchronizing and retrieving results from the GPU and comparing results of the GPU versus CPU execution time, and after that we are displaying results in performance. So basically the resources which have been applied here is an NVIDIA Jetson Nano, which is here power supply Jetpack SDK, Python, NumPy, CUPy, and function. So the procedure is given here. The first step is to display the execution modes to the user, which is CPU using an NumPy and GPU using CUPy, and after that we are selecting the specific execution mode based on their user input. For a CPU it is NumPy, and for GPU is for CUPy, and after that we are accepting the required input values such as vector size and input data, which are arrays A and B, and after that we are validating the inputs for correct numeric format and ensure compatibility with the selected execution mode on the NVIDIA Jetson Nano. And after that we are performing vector addition using the selected mode, and after performing we are displaying the computed output vector and correctly executing on the console, and after that we are allowing the user to repeat the execution with the different input values or modes for to compare the values and so on, and after that we can terminate the program whenever the user needs to exit. So this is the steps. The first step is to boot Jetson Nano and using inserting a SD card with Jetpack SDK and powering on and completing the initial setup. And these are the libraries which are to be installed: sudo apt update, pip3 install mpy, pip3 installs cupy, and CUDA 11x, and after that this is creating a Python 5 nano GPU text, and after that we are pasting this code, uh, CPU data, A CPU, B CPU execution, GPU data, GPU execution, and after that we are giving the sample inputs such as A is equal to 1, 2, 1.2, 2.5, 3.1, 4.0, 5.3, and in B it is 0.8, 1.5, 2.9, 3.0, and 4.7. And the expected output which have been given by both of these are 2.0, 4.0, 6.0, 7.0, and 10 respectively. And there's a slight difference here comparing to the CPU time than the GPU time. So the CPU has taken a lot more time, which is 0.0045 seconds, and in GPU which has been taken into 0.00030. And the observations which are observed here is that the experiment is basically performed on Jetson Nano by executing vector addition using CPU and GPU with CUPy. So we have observed that smaller input sizes, the execution time of CPU and GPU was nearly similar to the data transfer over. But as the data value of the vector size is increasing, the GPU time execution has become more low compared to CPU execution, which shows the improvement in parallel processing in GPU, whereas the output vectors in CPU and GPU are identical, but the time difference is makes an edge towards for the GPU for you know for easy execution time, and it helps to upload the data so quicker. And the results are given here. The vector addition obtained using CPU and GPU and NVIDIA are identical, confirming correctness of execution. GPU basically showed a better performance compared to CPU for large input sizes, demonstrating the advantage of parallel processing. While for smaller inputs, the difference was minimal due to memory transfer overhead. And the results basically indicate that the GPU based NVIDIA Jetson Nano is more efficient for large scale computations due to its parallel processing capability, and the identical outputs from CPU using NumPy and GPU using CUPY confirm the correctness and reliability of GPU computation. The minimal difference for smaller inputs highlights that the data transfer between CPU and GPU memory are more likely to be similar and same. And after that, the overall experiment shows that GPU acceleration is highly beneficial for data applications, improving execution time and computational efficiency. And overall, like conclusion here, the experiment basically concludes that the GPU execution on NVIDIA Jetson Nano is more larger. Basically, it improves performance for large scale computations through parallel processing, and it also confirms that GPU based computation using CUPY is more reliable than compared to the CPU, which is based on an NumPy, and hence GPU acceleration is highly suitable for data intensive and real time applications. So, yeah, there you go. And thank you.